to make sure we just kind of run down the multiple choice questions from the chi-squared multiple choice 2. I don't know if you were curious about how to do that, so I'm going to kind of run down these real quick. This is just asking me to put it into the chi-squared formula. I'm going to write down the observed, and then really what I need is the expected values, and then just simply plug those in to what we know as the chi-squared expected value, or how I calculate chi-squared values. And so what I know is that if you read through the paragraph, 20 note, does the day of the week matter? Like, well, let's assume that it doesn't matter, right? The null is always the absence of the thing I'm looking for. So let's assume that every day of the week you have the same number of disciplinary referrals each day. So that means it doesn't matter for the week. So we add them up, we divide by 5, and that gives us an average of 9 for each day of the week. Right? At that point, we have our observed, we have our expected. We can simply use the expected value formula. Not expected value, sorry. If we can use the chi-squared statistic formula, which really it says it's going to be the observed value minus the expected value, all of the top of that squared, all divided by the expected value. At that point, these questions, if you knew that formula, most of these questions that we're going to do today are pretty straightforward. They're pretty easy. And so I'm going to plug that in. I'm not going to do all of it. Obviously, if I can get just a couple of them, I can see the pattern, and then we can kind of go from there. And you can see that 12 minus 9 divided by 9. The next one would be 5 minus 9 divided by 9, or squared divided by 9. And then 9 minus 9 squared divided by 9, and so forth. And at that point, you can definitely see how you can eliminate those. If you look through the questions, I'm looking for the expected value. That means they're all 9. So I should see denominators all across the board as just 9. That one fact already clues you in to the right question, which is going to be answer choice B, because you see 9s across the bottom. Right? That's one thing I can focus in on. The other thing is, I know that the second number in the subtraction and the denominator all have to be the same. So keep that in mind when you're looking at this. Okay, so here again, this one's asking me, this is kind of an unusual way to do the problem. It's asking us to get the p-value for a goodness of fit test. But they're not going to give us the p-value, and they're not going to tell us how to kind of put it all together. But what you notice is that they're saying, hey, look, the chi-squared value is this thing, and we're going to use the chi-squared formula. And I'm writing it down so you can see it there, observed minus expected squared divided by expected, which means I know that I have the observed values. You can see those listed in the paragraph. You had 23 for ABC, NBC, and CBS, 17 for CNN, and 10 for Fox. Now, in order for me to really get this down, I need the expected values. I need to look at those in terms of what's my sample size and what's the percentages that I can work with. Well, I know that ABC, NBC, and CBS was 36%. So I'm going to do 0.36 times 50. And then for the rest of them, I'm going to carry that same process out. So we'll go ahead and just multiply each one. 0.36 times 50, 0.42 times 50, and for the last one, it's going to be, what was that? 20.22 times 50. And that'll give us the expected values. And this is what's going to go, if I were to actually carry this test out, these are the lists that I would use. GOF test always uses L1 and L2 as my two values, not a matrix. And so you got 18, 21, and 11. And back, just like the previous question, we're going to go back into that formula we see up top, plug them in, and really look for that framing. So 18, 21, and 11 should be on the denominator. And I can see that the answers C and D are the choices we have there. So if I write all of that out, the question is, what's my degree of freedom for a question like this? Remember, degree of freedom for chi-square is always the number, or chi-square GOF is the number of categories, or how many numbers you have in a list minus 1. We have 3 values in each list, which means I'm going to be subtracting 1 from 3. So I get a degree of freedom of just 2. Which this allows me to find the answer very quickly, which we can say is C at this point. All right, so next one. This is going to be we're looking at trying to find the chi-squared statistic. This one brings in something old, a good review question. This brings in normal distributions, and it goes back into 68, 95, and 99.7%. Now, if you're not paying attention, then that probably just went right over your head when you read this for the first time, because we're so focused on chi-squared. But it's asking us to get expected values. Remember, expected values, especially for the GOF test, I need percentages to figure out how many are going to be in my lists, in my L2. And so if I write out my normal distribution, we know how many, we know the percentages that come from, right? I can look these up, and these numbers, the scores, are going to correspond to values down here, right? We know the mean is 100. We know that the standard deviation is 10, and I got that just by using the number here and number there. And so I'm going to go in and I'm going to fill in the actual percentages that it's talking about. So between 90 and 100, I have 34. Between 100 and 110, I have 34. But then it says all below 90. And then it says above 110. We know that if you go above or below those values, this is technically 13.5 and then 2.35 and then if we add all that together, we get 16%. And then 16% from here down. And so I can look at these values here. And if I sum all these numbers together, what's my sample size? We know that we have a sample of 100 scores. We already had that here. And I can take those percentages, like what should be between 90 and 100. Well, 34%, so technically 34. And then 34 for the other one, and it was nice that it was 100. So then 16 for these. So I had 16, 100, or 34, 34, and 16. And you can see those here. And then I'm just really going to plug that into a little formula like we've been doing for the last few questions and figure out which one of my answers are correct, which leads us to B as the correct answer, because that we see the correct denominators and the correct ordering of observed minus expected, all squared divided by expected. At this point, we are changing gears. We're going to be looking at a two-way table this time. It's still asking me to really come up with my expected values and plug it into the chi-squared statistic formula. So I'm going to write down the observed values. You can see that they're given to you in the matrix, in the table on the screen. And then I can use a number of two things. I can talk about the row total times the column total divided by table total. I can do all of that to get each of the individual expected values for this. But because they've given us a matrix, it's going to be a whole lot easier if we go in and just look at the matrix A, run my chi-squared test, and come back with looking at matrix B, and then plug it into the formula. I wrote the totals down in case you wanted to kind of just double check if you wanted to try it the way with the formula. It's not a big deal, but I definitely wanted to know this formula for when if we ever take a test, who knows. Row total times column total divided by table total. Essentially, you're finding out a percentage and then multiplying it times or you're dividing it by the total in the table. But really, that's kind of extra, but you can see that for each individual piece one. I would have to do 4 different calculations for this. It's just a lot easier if we just use this in matrix A. So, take a minute. I'm going to plug this into my matrix and then come back with matrix B, and we'll see if we have the same things. All right, so matrix B, it was nice. It was all whole number values. Be careful. Sometimes it's not, and that's perfectly okay. Once I get all my expected values, now the values correspond, the observed value and its corresponding expected value in cell entry 1, like first row, first column, like 33. That's the observed, and its expected would be 44. So I'm going to plug that in to my equation, 33 minus 44, all squared, divided by 44. And obviously that pattern keeps on going. I'm not going to fill in the whole thing, but I'm looking to find that, and I can see I have a few options that kind of get the top right, but the top and the bottom combined, the only ones that really make that happen is answer choice A. On this particular video, it's on Google Classroom already. If you missed this question, you should have gotten a a link to a video on Classroom, and not Classroom, a video on YouTube, I think it was, that you could watch to see this one. This one was a whole other thing. This was probably the hardest one, so because it uses binomial distribution. So check that video out if you had a hard time with this one. Number 6, or 97, however you want to look at it. This one's actually quite simple. I could use guess and check on this. I think I mentioned that in the key on the form. If you try this one, you could do you could try the values just plugging them in to n, a, b, c, d, and e, and see which one gives you a chi-squared value of 0. That's kind of extra. It's a lot easier to make a proportion. So I know that they're supposed to be perfectly proportional. So 50 divided by 40 equals n divided by 60. I could have also flipped that over. It really wouldn't have mattered because I'm going to end up with the same proportion when I cross multiply. So I'm essentially going to cross multiply and just solve for n. That's pretty simple in this case. We're going to get n equals 75. That's the entire problem. All right, number 7. This one's not a very long question either. Here again, I'm looking to try to find expected value. This one gives me a specific value. It says problem solved and location 2. I'm going to use the row total times column total divided by table total because I think that going to my matrix, typing all those values in, doing the test, going back to matrix B, that's going to be more work for me than just doing a few addition problems and writing down the formula here. But it's completely up to you. I did it this way since I've already done it the other way with the matrix. I'm going to go ahead and just do the expected value for the position where 98 is. So if I look up the totals, or if I add the totals, I'll add the row that it's in. So problem solved row has to add up to, I believe, what is that? 161? No, 325, yeah. And then the 161 is the column total. And add those values together, we're going to get 500. So I need those 3 numbers. I'm just going to go in, plug those into my formula. So the row total times the column total, obviously it doesn't really matter which way you multiply. So 161 times 325 divided by my 500. And at that point, I don't really need to do the multiplication anymore. But here again, this is the form of my answer. And if I had done a matrix, it would have given me a specific number, and I would have had to have worked out each of the different options at the bottom to see which one actually matched up with my number. So sometimes it's helpful to look at my answer choices to see what kind of form they decided to solve it with. Hope this was helpful. If you have any other questions, please contact me through email or Google Classroom.